Okay, so get this. Today we're going deep on a paper that's like the holy grail of language AI. Attention is all you need. Bold title, right? And it totally lives up to it.
Okay.
This paper, it brought us the transformer model. And that, my friends, changed everything about how machines deal with language.
It really did. See, before this whole thing, if you wanted a machine to understand language, you use this thing called an RNN, recurrent neural network.
Right, RNNs.
So picture this. You're reading a book, but you have to read one word at a time. And every new word makes you forget the one before it.
Oof, talk about frustrating.
That's basically RNNs in a nutshell. Not exactly efficient.
Like trying to follow a movie plot, but you can only remember the last thing said, you'd be lost. So this paper, they just scrapped that whole idea.
Exactly. They were like, hold up, what if instead of word by word, we let the machine see the whole sentence at once? But in a smart way.
Okay, and that's where attention comes in. This is the core of it, right? Attention is all you need. Sounds deceptively simple.
It does, but the implications are huge. Think about how we read. We don't stare at every single word like it's a museum piece. Our eyes scan, they jump to what seems important, and our brain connects the dots. That's what attention mechanisms let AI do.
So instead of getting bogged down by every single word, the AI can grasp the whole sentence,
Yeah.
even a whole paragraph, like we do.
Precisely. And because of that, we have AI that can, say, summarize a whole report for you, or have a chatbot conversation that actually makes sense. Even translate languages really well now.
Yeah.
All because machines can pay attention like never before.
It's like giving a machine the power to not just read, but to actually understand.
Exactly.
No wonder this paper was a big deal. But how'd they actually do it? What's the magic inside this transformer thing?
So picture a crazy good translator, yeah. The transformer, it's got this elegant structure called an encoder-decoder. Encoder breaks down the input, like a sentence in English, into its pure meaning. Then the decoder, it takes that meaning and rebuilds it in, say, French, but with all the nuances still there.
Okay, I'm following. Encoder breaks it down, decoder builds it back up, but where does the attention actually happen in this process? Is it like sprinkled everywhere, or is there a specific spot in the transformer where it all goes down? So it's not just about the encoder and decoder doing their thing, there's more to it.
Way more. It all happens in these things called self-attention layers. This is where it gets really wild. It's like every single word in a sentence can suddenly look around at all the other words and figure out how they're connected.
Whoa, hold up. At the same time, not like one after another.
Exactly.
Yeah.
No more reading one by one. It's like the AI gets the whole panoramic view of the sentence in one shot.
Okay, so by seeing these connections, which words matter most, how they relate, that's how the AI really gets what the sentence is saying.
You got it. It's not just about knowing the words, it's about understanding the meaning. That big picture view is key.
This is blowing my mind a little, but hang on. If we're not going word by word anymore, how does the model know the order they're in? Because dog bites man is very different from man bites dog, right?
Ah, you're asking the right questions. See, RNNs, they knew word order naturally because they went in order. But the transformer needs a new trick, and that trick is positional encodings.
Positional encoding sounds like we're going deep into the AI metrics here.
It's actually super clever. Think of it like giving each word a little tag, a label that tells the model, hey, I'm word number 3 over here. The authors use these things called sine and cosine functions to make these tags. Sounds complicated, but it's a really slick way to give the model word order without needing to go one by one.
So even though it's not reading like we do, left to right, they found a way to make word order make sense to the AI. That's impressive. But you know what really struck me about this paper? It wasn't just theory. They had results, and those results were off the charts good. Like, they weren't just playing around. This was a total game changer.
Oh, absolutely. Remember those RNN limitations we talked about? The speed, the problems of long sentences? Transformers just blew them out of the water.
Okay, break it down for us. What should our listeners be most mind blown by? What did the transformer pull off that had everyone freaking out?
Well, first off, speed. Because transformers don't have to go in order, they can be trained so much faster. Like, we're talking way, way faster than RNNs, especially on huge amounts of data. It was a massive speed boost for AI research.
Okay, so that's huge. Time is precious in the AI world. But what about understanding those longer, more complex sentences? Did they nail that too?
Oh, yeah. Transformers aced that test. They were amazing at understanding how words related to each other, even when they were far apart in a sentence. RNNs really struggled with that, but because the transformer could see the whole thing at once, no problem.
So they solved the speed AA and the memory issue all in one go. No wonder everyone was buzzing about this.
It was a huge deal.
Yeah.
Like I said, they weren't messing around. When they showed their results, they absolutely crushed all the existing records, especially in translation. It was a landmark achievement.
So it wasn't just a win, it was like rewriting the rules of the game. Right.
Totally.
Wow.
But it's really cool. A discovery this big, there were bound to be some surprises along the way.
Oh, I bet. What kind of unexpected things popped up while they were building this thing?
Well, one of the big ones was just how powerful multi-head attention turned out to be.
Multi-head attention. Okay, now we're getting fancy.
Right. So at first, they tried using just one attention head to look at the whole sentence.
It makes it.
But then they found that if you use multiple heads, each one focusing on different parts of the sentence, way better results.
Ah, so it's like having a whole bunch of experts looking at the same thing, each with their own specialty.
Exactly. It's like giving the model a more well-rounded understanding.
I like it. More brains are better than one.
Right. And then there's the whole thing with the dot product.
Wait, the dot product, like from high school math.
Yep, that one. Turns out that simple little calculation worked amazingly well for figuring out how words relate to each other in a sentence.
You're kidding. Sometimes the simplest tools are the best, huh?
Tell me about it. Even the authors were a little surprised by that one.
So they solved this huge problem with, like, the most elegant solution ever. But this paper, it wasn't just about fixing the old stuff. It also hinted at some seriously cool possibilities down the road. Like, remember how they talked about making the generation of language less sequential? What's that all about?
Oh, man. That's where things get really interesting. So even though the transformer processes language all jumbled up, it still usually generates it one word at a time.
Yeah, that's how we write, right? One word after another.
Right. But the authors, they suggested that even that could be revolutionized.
Hold up. You mean instead of going letter by letter, AI could just spit out whole chunks of text at once?
Imagine that. AI writing a novel, not sentence by sentence, but weaving together whole chapters simultaneously.
Whoa. Or composing a symphony, not note by note, but whole movements at once. That's wild.
This paper, it didn't just change how we play the game, it invented a whole new game.
Mind blown. So to wrap this whole thing up, we've got this paper, simple title, totally changed how we think about AI and language.
100%.
And its fingerprints are everywhere. You ask your phone a question, translate a website, even scroll through social media. That's the transformer model at work.
It's true. It's had a massive impact.
It's like the invention of the microchip, but for language, a fundamental building block that's quietly changed everything. So, to everyone listening, if you want to understand the core of modern AI, this paper is a must-read. It's clear, elegant, just a masterpiece of an idea.
I couldn't agree more. Plus, it's a surprisingly fun read, even if you're not a tech whiz.
Well said. And on that note, we'll wrap up our deep dive into the world of transformers. Go check out the paper, let us know what you think. Until next time, happy exploring.